Hello students, welcome to my channel. I am your Manoj sir. I hope you are all doing well. Let's start today's lecture, which is about the continuation of the problems based on the reduction formula over 0 to pi by 2 sine power nx dx. In the previous lecture we did two problems. If you are not yet watched that video, please go through that once. And if you are a new person who is watching my lectures at the first time, please do subscribe to my channel. Your one subscription will motivate me to do further videos of beautiful concepts of mathematics. Okay, let us start today's lecture. The third problem is evaluate integration over 0 to pi by 4 sine power phi x into cos power phi x dx. Let us solve this. Solution. Let I is equals to integration over 0 to pi by 4 into sin x into cos x whole power phi dx. Okay, shall I write like this? Shall I write like this? Right? We can write like this. Okay, then I is equals to, when we compare the reduction formula for integration, in is equals to integration over 0 to pi by 2 sine power nx dx, right? Sine power nx dx. We have here, we have the reduction formula for this, for integration over 0 to pi by 2 sine power nx dx. But here there is sin x and also the cos x, sin x into cos x, right? So we have to reduce to this sin x into cos x to sin x, sine power nx form. Okay, so for this we can, and also there is the limits are 0 to pi by 4 in this problem, this equation. But in the reduction formula for integration over 0 to pi by 2, there is 0 to, the limits are 0 to pi by 2. So we also reduce this to this pi by 4 to pi by 2 also, right? So let us solve this. In is equals to integration over 0 to pi by 4. I will take multiply and divided by 2 sin x into cos x whole power phi dx. Okay, then I is equals to integration over 0 to pi by 4. I will take this 1 by 2 power 5, that is, what is 1 by 2 power 5? That is that is 1 by 2 power 5. 2 power 5 is 32. So 1 by 32 I will take outside and I will write 2 sin x into cos x whole power phi dx. Okay, did you understand? Or you can, if you are not understand, please you can write, okay, 2 power 5 only. Okay, 2 power 5. Let us do this. Okay, I is equals to, now I can take 1 by, what is 2 power 5? That is 32, right? 32, 1 by 32 integration over 0 to pi by 4 into, what is 2 sin theta into cos theta? 2 sin theta into cos theta is sin 2 theta, right? Sin 2 theta, here there is x, we are writing x here. So sin 2x whole power phi dx, and I is equals to 1 by 32 integration over 0 to pi by 4 sine power 5 2x dx. Right? Did you understand up to here? Okay. Then put here, to apply the reduction formula we have, we should have sine power 5x, right? But here there is 2. To reduce this to sine power 5x dx, we have to put, let's put 2x is equals to t. Okay. When we differentiate this with respect to t, we get 2 dx is equals to dt, right? 2 dx into dt, 2 dx is equals to dt. That is we can write dx is equals to dt by 2, right? dt by 2. Now let us put, there is limit right here. When x is equal to 0, when x is equals to 0, what is the t? What is the t value? T value is also 0, right? So when we put x is equals to 0, 2 into 0 is 0. So t is equals to 0, right? Then when I put x is equals to, the upper limit is pi by 4, right? So when x is equals to pi by 4, then we get 2 into pi by 4 is equals to t, that is 2 ones are 2 twos are, where t is equals to pi by 2, right? So t is equals to pi by 2. Okay, did you understand? Okay, let us substitute these values in I. Okay, in this. Okay, then I is equals to 1 by 32 integration over 0 to, now it is in the form of t, right? So we differentiate with respect to t. When we take 2x is equals to t, right? So 0 to, when x is 0, when x is 0, t is 0. So t is 0. When x is pi by 4, t is pi by 2. Let us write here pi by 2. Then sine power 5, here what is 2x? 2x is t. So let us substitute here t. And what is dx? Dx is dt by 2. dt by 2, right? Then I is equals to, let us multiply this 2 to 32. That is, it will become 1 by 64, right? 32 into 2 is 64. So in integration over 0 to pi by 2 sine power 5t dt. Now it is in the form of integration over 0 to pi by 2 sine power x dx, right? So now we can apply the reduction formula over 0 to pi by 2 sine power nx dx. So then by considering this, we know that n is equals to, pi, right? N is equals to pi. So n is equals to pi, which is odd. Pi is odd, right? Pi is odd number. Then when n is equals to 5 or odd number, we have the formula particularly for that, right? From the introduction, from the integration over 0 to pi by 2 sine power nx dx reduction formula. So that is the reduction formula over integration 0 to pi by to sine power nx dx, we have in is equals to n minus 1, n minus 3, n minus 5, so on up to 1. 1, is it 1? No, it is 2. So 2 n into n minus 2, n minus 4, so on up to 3 into, that is I1, right? The last integral, when we have n is equals to 5, that is odd. The last integral should be I1, right? So we get I1 here, and also we know the value of I1, right? What is the value of I1? We did it in the reduction formula. Reduction formula was 0 to pi by 2 sine power nx dx. That is, the value of I1 is 1, right? The value of I1 is 1. Let us write it neatly. 1. We know that n is equals to pi, right? So let us apply here. That is, I5 is equals to, here we have 1 by 64, right? We have to write it here. That is 1 by 64 into, now we can write 5 minus 1, 5 minus 3. 5 minus 3 is 2. At the last we have to get 2. So let us end it here, and n is 5. 5 into 5 minus 2. What is 5 minus 2? 5 minus 2 is 3. At the last we have to get 3. So 5 minus 2 into 1. Okay, did you understand up to here? Okay, let us simplify further. That is, I5 is equals to 1 by 64 into, what is 5 minus 1? 5 minus 1 is 4 into 5 minus 3 is 2 divided by 5 into 5 minus 2 is 3 into 1. Okay, then I5 is equals to 4 ones are 4 16s are, right? 16 fours are 64. Then 2 ones are 2 eights are, right? So we get 1 by, what is 5 eights are 40. 40 into 3 is 120, right? So this is a required solution for the given problem. Okay, so let's solve the another problem. That is, the fourth problem is evaluate integration over 0 to 1 x cube divided by root of 1 minus x square dx. Let us solve this. Solution: let I is equals to integration over 0 to 1 x cube divided by root of 1 minus x square dx. Okay, now I will put x is equals to sine theta. Okay, x is equals to sine theta. Now let us differentiate with respect to theta. Okay, but here when we compare the reduction formula 0 to, that is Im is equals to 0 to pi by 2 sine power nx dx. Here the limits are different. 0, here there is 0 to 1, but here there is 0 to pi by 2. We have to reduce this 0 to 1 to 0 to pi by 2, and also we have to reduce this x cube divided by root of 1 minus x square to sine power nx dx. Okay, so for this I will take x is equals to sine theta. Okay, when we differentiate with respect to theta, we get dx is equals to sine cos. Okay, so what is differentiation of sine theta? That is cos theta into d theta, right? So we get this. So, and there is a limit here. So when we take x is equals to 0, then what is theta? Theta is what we get when x is equals to 0, sine theta. So theta is equals to, here sine theta will shift it to the denominator, then it will become 0 by anything is 0, then theta is equals to 0. Then when we take x is equals to 1, when we take x is equals to 1, we get, when we put, I will write it here, that is when x is equals to 1 is equals to sine theta, right? So theta is equals to 1 by sine, right? 1 by sine. Theta is equals to, we can write sine inverse of 1, right? Sine inverse of 1. What is the value of sine inverse of 1? That is theta is equals to pi by 2. Sine inverse of 1 is pi by 2. The value of sine inverse 1 is pi by 2. So when x is equals to 1, theta will become pi by 2. Okay. Okay. Let us substitute these values in the equation 1. Let's take this as equation 1. Okay. These values in the equation 1. That is I is equals to integration over 0 to that is 0 to pi by 2. Let's take 0 to pi by 2. When x is equals to 0, theta is equals to 0, right? When x is equals to 1, theta is equals to pi by 2. I will write here pi by 2. Then what is x? X is sine theta, which means here there is a cube, right? Sine cube theta divided by root of 1 minus sine square theta, right? Here what is dx? Dx is cos theta into d theta. Okay. Now I is equals to integration over 0 to pi by 2 sine cube theta divided by what is let us take root, what is 1 minus sine square theta? 1 minus sine square theta is cos square theta, right? Cos square theta into cos theta d theta. Here square and square root cancel, and I is equals to integration over 0 to pi by 2 sine cube theta. Here we have only cos theta. Here also there is cos theta d theta. So cos theta get cancels. I is equals to integration over 0 to pi by 2. We have sine cube theta d theta. Now it is in the form of integration over 0 to pi by 2 sine power n x dx, right? So now we can apply the reduction formula for this. So what is the reduction? And also we know that n is equals to 3, right? 3, which is odd. Then we have the formula, reduction formula for n is equals to odd, right? That is in is equals to n minus 1, n minus 3, n minus 5, so on up to 1, that is 2, whole divided by n into n minus 2, n minus 4, so on up to 3 into I1. The last integral is I1 when n is equals to odd. N is odd. That is, we can take, we know that n is equals to 3, right? So I3 is equals to 3 minus 1. 3 minus 1 is 2. At the last we have to get 2. So this ends, and n is 3. So at the last we have to get 3. So we get 3. And what is the value of I1? We know that I1 value is 1, right? Then let us simplify this. So 3 minus 1 is 2, 2 by 3, right? So this is a required solution for the given problem. So this ends this lecture. Let's meet you in the next lecture. Until, take care. Thank you. Bye bye. God bless you.